Hi guys, welcome to another Learning Electronics Repair video. I have a little package here from PCBWay today, slightly bent in the postage, thank you DHL, but it's arrived in one piece. PCBWay kindly sponsoring this video, I will just mention, and they did send me these PCBs for free. What I have here is a selection of PCBs from their shared projects section. So basically, if you don't know about this, PCBWay.com have a shared project section where people can upload projects, and anybody who wants to build that project can click on the link and order the PCBs without putting any other information in. Very simple to do. The PCBs come in a pack of 5 and generally cost €5, so about €1 per PCB. Postage varies depending on how you want them to send them, but if you order a few different ones, it can still work out even with the postage at less than €2 per PCB. So they invited me to have a look through the shared projects, and I had a look through trying to find interesting DIY repair related projects, so gadgets and test equipment we could build cheaper than we could buy to make our life easier. The other great thing about the shared projects is that if you have some project or idea, you could upload the Gerber files, the bill of materials, the schematics, link to your own web page describing the project or video describing the project. And if somebody wants to buy one of your projects, you make yourself a 10% commission. You don't have to keep anything in stock. They just, when they want to order, just order the PCBs and you get your commission. So let's have a quick look at the shared section and I'll show you what's in the box. I have 6 different PCBs here, and what I'd like to do is have a look through them and to see whether these projects are worth building and would save us money. Okay, let's have a quick look at the website and then we'll get on to the fun stuff, yeah? So this is the shared projects section. I'm on page 2 of 6 at the moment. They divided into categories and subcategories, as you can see. And I have not looked all through these. I mean, there are thousands of projects on here. Many of them are under this category of DIY electronics, almost 4,500. This is where you can create your own projects. And really, you can either search for some keywords or just have a look through. And what I did was have a look through to see if I could find anything interesting from a repair point of view. So I'll just very briefly show you. We go into a DIY. And let's have a quick look down here and see. And also on here, by the way, you can actually now purchase the Learning Electronics Repair $1 Amazing Short Finder, the updated version. But let's have a quick look at these things that other people have put on here. So we'll just click through a little bit. Oh, there we go. That's our short tracer. It's there, yeah? It's there. You can build your own Hacko 907 digital soldering station. And you can do lots of things on here. You can buy lots of things on here. And you can upload lots of things to here. So it's a great little place. I like this a lot. So we can see there's plenty of things to actually order. I had a quick look through and just grabbed a few items that I thought may be interesting and may be feasible to build, but I haven't had a good look. So if you guys like this video, and I'm going to propose to build a couple of projects when the parts turn up. There's 2 projects I like out of these 6. But if you've got any suggestions, get on here guys, let me know what you'd like me to investigate, and anything I think and you think we can build ourselves and save money, or build ourselves and make better than we could buy, then yeah, let's do it. So I guess what you all want to know is what's in the box. Yeah, well, we have some stickers. 7th anniversary 2021. I do know it's the 8th anniversary 2022 coming soon, so probably in the future we'll get some 8th anniversary stickers. A nice pen. PCBWay. Oh, it's one of them ones that writes really nice. I like that. Okay, that'll get used on some of my Dicky card schematic diagrams. Yeah, that's for sure. And we have some PCBs. This one in red. I think I actually chose to have this one in red. So they sent 5, so it's like €5 for 5 PCBs. Or was it $5? I'm not quite sure. I think my price was in euros. But anyway, this one uses an Arduino Nano, and this is a RF signal generator. And the thing with this for me is that I do not have an RF signal generator in the workshop. So this will generate from 10 kilohertz to 255 megahertz. It has an OLED LCD display displaying the frequency and the signal strength. And I think because I've been doing some radio repair and also wireless microphones, I did one yesterday, this could be quite a handy bit of equipment if it's not expensive to build. They're quite expensive to buy, and because this is effectively an open source project, we might be able to add a modulator on this quite easily, so we can effectively create AM or FM modulated signals to test RF equipment. So we have that one, which I'm quite interested in building. This one is quite a small PCB. Yeah, little PCB. This is a surface mount project. Tiny load. So this one is an electronic dummy load. With this, we can effectively connect a power supply, and we can put a load from 0 to 4.5 amps with this on the voltage rail. And on the display, it will display the voltage, the current, and the wattage being dissipated. Although this only goes to 4.5 amps, I think it might be possible to expand this using more MOSFETs in parallel to get easily, say, to 20 amps or something like that. And because they're quite small, you could put 2 or 3 of these in one case and build a little load, for example, for loading ATX power supplies on each voltage rail. So that's a fairly interesting one. We can look at that one. And again, I don't have anything like that in the workshop. The next one, yeah, this one. This is another green PCB. I have to say these PCBs are nicely made. They're good thickness. They're very solid. This one is a MilliOhm meter from Electrolab. So, as a lot of you, I'm sure, already know, I designed a project about 4 months ago, the amazing $1 short finder. And then, just last weekend, I made an updated version of that with the help of Detlef Amend and Carlos from Retro Upgrade. The new versions were USB powered and or battery powered, and in fact that project, as you've just seen, one of them is on the PCBWay shared projects. So you can order those PCBs if you want to build that one, and myself, like anybody else uploading projects, will get a 10% commission. So if you'd like to support the channel, yeah guys, if you want to build that, great. This, however, is something a little bit different. So the one I built basically does not display the resistance. It displays a voltage of millivolts down to 0.001 millivolts or 1 microvolt, and that 1 microvolt equates to 20 microohms. But the one I built was not designed to measure low resistances. It was designed to find short circuits by finding the lowest reading in microvolts. This one will actually measure the resistor. So I thought this could be an interesting project again to build, and let's see how that compares in accuracy and sensitivity to the one I designed. And I think if you actually want to measure the resistance, this is almost certainly the better way for that. So that's that project. There's a few more. This one, LC meter. Okay, this is an accurate inductance and capacitance meter, but it only measures small value capacitors up to about 0.1 of a microfarad. But what it will do is measure inductors from practically zero, less than 1 microhenry, to more than 10 millihenries. And I don't have an inductance meter. I can use my ESR meter and effectively calculate the inductance by doing some maths. But this, I thought, might be a nice little project if we want to measure inductors. So we have that one. And 2 more. This one, nice orange PCBs. You can see the variety of what they actually produce. This one is quite interesting, actually. This is designed to make a soldering station to drive Weller soldering iron tips. I'll just tell you, if you give me 1 moment, which tips it actually works with. Yeah, it drives the WMRP and the WMRT Weller tips. Now, the handles are quite expensive, but as part of this project, there's a 3D printed project to actually make your own handle, and a small PCB that goes in the handle, which is also on PCBWay, to drive the tips. So you can buy the Weller tips. The difference between the P and the T is the SMD tweezers and the P is a standard bit. So you can buy the tip for about 25-30 euros, depending on which tip you want to buy. And then you can build the soldering station and actually effectively 3D print a handle and have a Weller compatible soldering iron. I thought that might be interesting, especially to see how that performs against the T12. Which brings me to the last one we have in here. So this is a similar project for a soldering station, but this drives T12 tips. So you can make your own soldering station, very much like my one I have here. This is the KSGR. You can buy the handle, you can buy the tip, and you can build the soldering station, the controller. So that's that one. So I guess now we know what we've got in the box. The interesting thing would be to have a look to see how cost effective it would be to build any of these projects. This is the first one. This is the signal generator. There's not a lot of components in this, and all the resistors and capacitors basically I already have, and a few bits and bobs. So I had a look at the bill of materials, which I will show you, and figured out what I don't have, and then had a look on AliExpress to see how much it would cost to buy the parts. So this effectively, I only need these 3 modules. So this is the price on AliExpress including VAT, and this is the postage including VAT. The inductors, I think they were in a pack of 10 or 20, I can't remember. There was more than one in the pack. So that's all the stuff I would need to buy. With the postage, this plus this together came to 1561. So it was quite cheap, but for a reason I'll just explain. I see the price including 21% IVA, which is the Spanish equivalent of VAT in the UK, and whatever else they call it if you have it where you are. So because I'm in Spain, it sees the VAT and automatically adds it on. But although I'm in Spain, I'm in the Canary Islands, and we don't have VAT in the Canary Islands, we're exempt. So what happens is when I go to checkout, it automatically deducts 21%. And I see this price, but unless I buy, I can't see the price unless I calculate it myself. So that's what I've calculated. So that was the price to build this project. Not including the fact that if I order this, I'll get a little bit of a saving on the postage as well, because they generally combine the items. I think these 3 all came from the same supplier to start with. So let's have a quick look at this project, but I'm going to give this one a yes, because I want to build this. I have nothing like it, and it's quite inexpensive. So let me just show you now what we have in this project, and then you can let me know your thoughts below if it was a good idea. But by the time you've done that, I'll probably have ordered the bits for this one anyway. This is the project on PCBWay. Doesn't give a lot of information, but I effectively just googled for this and it took me to the actual project, and this is the same project. So you can see now what we need. This was built on breadboard, but I've ordered the PCB. So I had an encoder. I didn't have these. I have switch. I have jack sockets, and the capacitors and resistors I have. I had to order the inductors. So you can see what I needed to order myself and what I already had. That would give you some idea if you wanted to build this. So this explains basically what it is, and it looks like an interesting project to build for me, so that's what I'm going to get on and do. The schematic is there, and it goes on to various examples of it in use. So let's have a play with that one. I've had a look on AliExpress for RF signal generators, and anything in this sort of range is going to set me back a couple hundred euros for a professional tool, and I'm not sure I do enough of this type of repair to make that justifiable to me at the moment. So that's another reason why I'd like to build this one. So that's a yes. The LC meter worked out, again, the same sort of thing. The cost, this is the postage added together is this, less the VAT, comes to like 19 euros. Now this one I'll just show you also on AliExpress and on PCBWay, because there's not a lot of difference as I can see in the cost of building this to actually buying something. This is the project on PCBWay. You can see it's really intended for radio use, so it only measures low value capacitors. This was the more interesting to me, that it measures inductors from practically 0 microhenries up to 10 millihenries. The project is here. We have the schematic for this one and a lot more information. I had a look at this, and I only needed to buy certain things. The main expense of this was these polystyrene capacitors. Apparently these capacitors have to be very accurate. You can't use normal ceramic or like the green capacitors that you find. You need to use these types, and 2 of the capacitors were actually the most expensive part of the whole thing. I had some tantalum capacitors already. All the rest of the resistors and capacitors are standard, not critical. I have crystals, which came in a pack of 10. That's the PIC, the relay, and the LCD display. So I figured this one, as I say, was about 19 euros. I then had a look, and I can actually buy inductance meters for about that sort of price anyway. What this guy is saying is this one is very accurate. So the only reason I think this would be worthwhile to build is for 2 reasons. One, if some of you guys actually want to see it. And 2, if I then also got a commercial inductance meter at 20 euros and had a look to see if it's more accurate. So at the moment that's a kind of a maybe. But only really if there's some interest from you guys. This was interesting. This is the T12 station. When I saw this, I thought, hey, you can make these really cheap. But it's all surface mount, and most of the stuff I didn't have. So I started touching up, and although I only needed 1 of these, mostly I was having to have to buy them in 10s or 100 of those. It was just cost effective. They came in 20s and so on. So in the end with this, by the time I'd built it, I would actually be paying, without the case, 33 euros. And you need a power supply for it. So it's not, to me, a cost-effective proposition to build these yourself. I think there's just so many cheap ones to buy in China that it kind of becomes not really any point in doing this. I think the only reason you'd probably build this project, to me, was 2 reasons. One, if you want to build something yourself because you know how safely it's being built. Yeah, the quality of the power supply and whatever. And the other one was quite interesting. All these here is enough bits to build at least 10 of these. The only things that were in one was the AT Mega and the OLED display. Okay. and the socket. This is the socket that actually connects to the T12 soldering handle. So when you weigh it up, the cost of those bits is like €1.20, and this one was €4.73, so you got about €6, and the other one was about €3, €1.59 plus a bit of postage. So it kind of worked out that if you were building 10, it actually works out at $3.36 per unit, and if you bought enough of those three items to make 10, it cost you another €6.20. So in the end, if you were building 10 of each, you're at €9.50. So if there's a group of you, or you're running some school class, or you have some reason why you want 10 or more, then this very quickly becomes cost effective. But I'm not in that position, so to me that one is a no. This is interesting. This is the Weller WMRP station. I'll just show you the project, and you can see the prices here if you want to have a quick look. But I'll just show you the project, and then I think this might be a yes, and I'll give you my reasoning why. Here is a project on PCBWay. Now you can see it's quite well rated. All projects in here, by the way, have people vote. They have ratings. We can see it working here. So this you can use with genuine Weller handles and tips. It uses a 12-volt power supply, and there's a link, this one, which takes you to here. So this is a lot more information about the project. You'll see that you can actually use the genuine handles, but they're quite expensive. Or you can build your own. So there's 3D printing plans here to make your own handle, to make your own stand, and then all you really need to buy is the tips. We have the tweezers as well. You can actually build compatible tweezers, SMD tweezers, to use with it, and the little PCBs for this are on PCBWay as well. There's also a little PCB that goes in the handle. It's on PCBWay, so that we can do. What really interested me here is the chance to build, hopefully, the equivalent of a very expensive soldering station for, well, you can see, about €26 to build it. I need to find a 12-volt 6-amp or 10-amp supply. I would think I would use an ATX supply and build it into an old box of some sort. I have salvaged, I'm sure. And the same for the tip. So in the end, I'm going to spend about €51. I'm very happy with my T12 soldering iron. I'd be interested to know how good these are compared to the T12. And I don't know. If I did some research, I know it's only about 40 watts, whereas the T12 is more like 70 watts. Whether it performs as well or better than the T12 will depend on the tip design. So it's something I'm interested to build, but it's something that's going to cost a reasonable amount of money, even though it's much cheaper than buying the complete item. So that one, comments below, guys. What do you think on that one? But for now, I'll say yeah, maybe. Let's look at the electronics load. Is it worth building an electronic load? Well, again, I'll show you the project and then see what you think. This is the tiny load. It has very good ratings, 10 stars across the board, yeah. Unless his mates voted for it. Or one person voted for it. But anyway, simple dummy load. You can see it built here. You can use it for load testing batteries, load testing power supplies. So that's the actual project. We have a schematic. It'll handle up to 26 volts, which is more than enough for anything I would want to do, I would think. So all the information is there. Oh, there were 3 volts and 3 votes, maybe his mates. But no, let's give this guy credit where it's due. Yeah, it may well be a very, very good project. So that's this one. Now let's have a look at how worthwhile this is. Well, you can see what it would cost to build. And at first, view, it seems not really worthwhile. By the time I'd had to order most of the parts for this, and I think one part or two parts were a bit pricey, or I had to get them in large quantities, you know, just to make it worthwhile. So you can see again, everything I have here, I have 10 of, apart from the OLED display and the AT Tiny. Okay, everything else. So I have enough to build, you know, I have 5 PCBs to start with. So what makes this interesting to me, I know I can buy a dummy load, single voltage, which will handle more current, cheaper than that. But what I could do, because I have all the rest of the parts, if I add another roughly €4.70 onto the price, I can put another channel on. So we have the cost of building €26. But for about another €10, I can have a 3-channel one. So for like €36, I can have a triple channel. And that is probably a worthwhile project for the price, I think. I'd be very interested to see how easy it is to modify this to handle more current. And I would have thought that it would do that easily if you use a number of MOSFETs in parallel. But you may have to alter the firmware to display the current. I'm not sure if that has some limitation. But because it's open source, you know, I can speak to the guy, I'm sure, and find some information or look at the schematic and then maybe work something out. So that's a kind of a, it's a kind of a yes. That's a kind of probable, actually. So I'll put a question mark, but I think it's worth building a 3-channel one, especially if I find some old bit of hardware with some big heat sinks in it that I can take out of it, like a scrap amplifier, for instance, which I might well be able to find around here. And lastly, we have the MilliOhm meter. MilliOhm's a very difficult word to say sometimes. MilliOhm meter. Okay, so we have that. This is a project. Again, it's got good ratings on here. This is on PCBWay. This says it reads to 10 milliohms. I'm sure that's milliohms rather than microohms. It uses op amps to do it. I've had a look at the schematic. The bill of materials is here, which I actually downloaded, so we can look at that. You can see it's a very simple device. These are all through-hole components, so resistors and capacitors I have. TL431s, I have loads of salvage ones. These diodes are 1 watt 3.3 volt Zeniths. I have them, but they're not expensive. I didn't. The diode I have. Variable resistors I have. So the only things I really didn't have for this was this OP07. This is an op amp. I need 2 of those. And then there is the MOSFETs, the IRF MOSFET. There's one, which I didn't have the correct type. I may have something compatible, but it's not expensive to buy. And what it says here is meter, which is a little bit vague. So I'll just show you what the meter is that he uses on this. This is the meter module. Comes in various prices depending on the colour, and for some reason the cheapest one is the yellow, and I quite like the yellow one. So that's the expensive part of this, if you like. Everything else is very cheap. So let's see how worthwhile this is to build. So there we have it. I can get 2. I need 2 of the OP07, but I can get 10 for like 87 cents and 112 postage. The IFPFZHDOs, I can get 10, work out about €6 with the postage. And this is the test meter of 656, 216 postage. So basically that's the cost with VAT. This is the cost of that VAT. So the cost of parts for this one is €14. He builds a project using a power supply in a case. I think this is the sort of thing you could very easily build into something like a scrap satellite receiver case, which I can probably pick up for next to nothing. So I'm interested in building this one. The cost of the parts is very cheap, and I'm very interested to see how this compares to the $1 short finder that I built. So this one is a yes. Okay. So to sum up, really, I'm going to order now the parts for this one. I'm interested to know what you guys think about building a triple channel electronic load and modifying it to handle more current. I'm very interested to know how good are these Weller stations. If they're good enough, I'll build it. I'm sure Carlos will help me with the design of it and the mechanical, any 3D printing, and we can then compare it with the T12 to see how well it works in comparison. This isn't worth it for me unless I was building a lot. This one, yeah, maybe 20 euros. Yeah, I'm sure I can find some sort of box to stick that into. And this one I'm going to order today because I've been looking for a signal generator. Anyway, there we have it, guys. I have two projects to build straight away. So one is the RF signal generator and the other one is the MilliOhm meter. This because I want one and it's a very good price compared with buying one, and this because I want to see how well it compares against the thing that I built, the short finder, although they are slightly different. The dummy load I'm almost talking myself into. If we again can improve the current handling of it. So I'll do some work on that project, and then hopefully next month I might order the stuff and build the triple dummy load. The Weller, the LC meter I'll leave to you guys, and I'm sure you agree with me that the T12 soldering stations were not worth building. I hope you enjoyed that look at projects and building our own test equipment and tools to help us now repair. So let me know, get into the comments please, let me know anything else you'd like to see built. Let me know if you want to go over to the Discord and where we're working on our own projects, and I will leave you with that. So I will see you all soon on another Learn Electronics Repair video. Ciao for now, guys.